In this video, we're going to get some more practice factoring trinomials with a leading coefficient that's not 1. And in this case, we're going to have a couple of examples where there's a GCF that we need to factor out first. So regardless of what you're factoring, or the method that you're going to use or what have you, always look for a greatest common factor. Okay, so in this first example of 60x squared plus 250x plus 140. Okay, well, I don't have a variable I can pull out, but look at those numbers. They're pretty big, right? And let's see, minimally I can pull out a 10. Sometimes it helps to just pull out what you notice, and then you can look at what the leftovers are and see if you can pull out anything more. So if I pull a 10 out of 60, I'm going to be left with 6, right? So 6x squared, and then 250 divided by 10 is 25, so plus 25x, and then 10 times 14 is 140. Okay, so I'm looking at that trinomial that I have left over, 6x squared plus 25x plus 14. The only factor of 25 is 5, which doesn't divide 6 or 14. So I think we're done with that in terms of the GCF. But now let's look at that trinomial of 6x squared plus 25x plus 14. Does that factor? Okay, well, we've got 6 times 14, right, for the AC piece, and 6 times 14 isn't even in the times table, so I got to work that one out. So let's see, 6 times 4 is 24. 6 plus 2 is 84. Okay. So we're looking for factors of 84 that add to 25. Well, and we're adding everywhere, right? So they're both positive. So let's think about them all. Obviously, 1 and 84 isn't going to work to get us to 25. 2 and 42 also won't work. So 3 times what is 84? It wouldn't be, I always think of like 3 times 30 because that would be 90. So it would be something less than that. Let's see, 3 times 28 would give it to us, right? That would get us to 84. But 3 and 28 would be giving us 31 as a sum, and that's not going to work. Let's see, 4 goes in there 21 times. Ooh, 4 and 21. Does that give us 25 when we add them? Yes, 4 plus 21 is 25, and 4 times 21 is 84. Okay, so careful, when you've got the GCF, it's easy to just concentrate on the trinomial and forget about it, but keep that as a part of the product, right? So, so we're going to have 6x squared plus 4x plus 21x plus 14. And again, it doesn't matter the order of the middle terms. It'll come out the same way. Okay, so now we got to group them. Group the first two terms and the last two terms. And so from the first grouping, I'm going to change my parentheses here so we can see what we're doing. So 6x squared plus 4x, what can I pull out of that? Well, I can pull out a 2 and an x, right? So then we're left with 3x plus 2, right? 2x times 3x is 6x squared. 2x times 2 is 4x. And then in the second grouping, 21x plus 14, 7 is a common factor of 21 and 14. So I'm going to pull that out, pull a 7 out. So we're going to have 7 times the quantity 3x plus 2, right? We distributed that back through, we're going to get 21x plus 14. Good. All right, now factor out the 3x plus 2, right? That's the common term to both of those. And then what will be left over? 2x plus 7. Right, okay. So the fully factored form here is 10 times the quantity 3x plus 2 times the quantity 2x plus 7. Okay. So let's check that, right? 10 times 3x plus 2 times 2x plus 7. Work this backwards, see if we get what we started with. Okay, so leave the 10 alone and just FOIL for a minute. 3x times 2x is 6x squared. 3x times 7 is 21x. 2 times 2x is 4x. And 2 times 7 is 14. Okay. So I'm going to clean up that middle term. 6x squared, 21x and 4x is 25x plus 14. And then distribute the 10 through. So 10 times 6x squared is 60x squared. 10 times 25x is plus 250x. 10 times 14 is 140. Okay, so we end up with 60x squared plus 250x plus 140. And that is the original expression that we started with. All right, so now we're going to look at this next example of 16y to the 6th minus 28y to the 5th plus 6y to the 4th. So first I'm looking at the numbers. 6 does not divide 28 or 16, but its factors are 2 and 3. All of these numbers are even. 3 does not divide 16 or 28, so let's go with 2. We can factor a 2 out, and then amongst the variables, we can pull out a y to the 4th, right? That's the lowest power, so 2y to the 4th times 8y squared is 16y to the 6th. 2y to the 4th minus 14y would give us negative 28y to the 5th. 2y to the 4th times 3 would give us 6y to the 4th. Okay, now that we have the GCF pulled out, now we're looking to utilize the AC method on the remaining trinomial of 8y squared minus 14y plus 3. So if we multiply the a and the c together, that's 8 times 3, which is 24. Now the last term is positive, but the middle term is negative, which means both of the numbers we need to be negative, and they need to sum to negative 14. Okay, so what are the numbers that we're seeking here? With 24, I think 1 and 24, 2 and 12. Oh, 2 and 12. That might be lovely because negative 2 times negative 12 is positive 24. Negative 2 minus 12 is negative 14. Okay, so those are the two numbers that we're going to use to rewrite the middle term. And like I said, don't lose that GCF. Keep that with the whole thing. 8y squared minus 2y minus 12y plus 3, right? So I'm using those two factoring numbers to rewrite the middle term. And now I need to do the factor by grouping. So I'm going to group the first two terms and the last two terms. So now remember, when both of those terms in the middle are negative, you have to factor a negative out from that last term, right, when you group them. 2y to the 4th times the quantity in the first grouping, 8y squared minus 2y. I can pull out a 2y, right? So I'll be left with 4y minus 1 when I pull the 2y out. And then in the second term, 12y minus 3, I can pull 3 out, right? And I already pulled out the negatives, so we're good there. And we'll be left with 4y minus 1. Okay, so remember when I pulled the negative out when I did the grouping, think about it, once you pull out everything you can pull out, you're really distributing not 3 back 3, but negative 3, right? So you'd have negative 12y plus 3 there at the end. Okay, so now, but let's look at this, where we are with the factor by grouping. Now we've got two terms that both have a 4y minus 1. So now we can pull out 4y minus 1 and 2y minus 3 will remain. Okay, so we've successfully factored this as 2y to the 4th times 4y minus 1 times 2y minus 3. Let's check it. 2y to the 4th times 4y minus 1 times 2y minus 3. I'm going to come down here, running low on room. So again, leave the GCF alone and just do the FOILing. 4y times 2y is 8y squared. 4y times minus 3 is minus 12y. And negative 1 times 2y is minus 2y. And negative 1 times negative 3 is positive 3. Okay, so 2y to the fourth times 8y squared, negative 12y minus 2y is minus 14y plus 3. Okay, and then we can distribute the 2y to the fourth back through. 2y to the fourth times 8y squared is 16y to the sixth. 2y to the fourth times negative 14y minus 28y to the fifth. And 2y to the fourth times 3 is 6y to the fourth. Okay, and is that what we originally started with? It is. Very good. Okay, so sometimes that checking process can almost take as long as just the factoring process itself. And again, is checking mandatory every time? Certainly not. I do it here in the video because I want you to not only do we want to verify that it's correct, but we also it's helpful to kind of see how what we did is really the reverse of the foiling process. Okay.